Okay, here's another WOW video here. Part 284C3K35. It's line 22f1fa19c3k35. EDTA Chelate, Ligand, Ethylenediamine, NMR, GaAs or GaAs, Wow Seti. I'm supposed to have a space. Okay, so there's the alien radio signal, and then there's this little graphy thing here. That's a Metal-EDTA Chelate. And a quote from WIKI, Chelation. That's what it is there. Quote, Chelation is the formation of or presence of two or more separate coordinate bonds between a polydentate, multiple bonded ligand, and a single central atom. Just so you know, we've done several videos about the ligand in the metals and transitioning metals, so this is about the outer shell for the UFO. Okay? Usually these ligands are organic compounds and are called chelates, chelators, chelating agents, or sequestering agents. The ligand forms a chelate complex with the substrate. Chelate complexes are contrasted with coordination complexes composed of monodegenerate ligands which form only one bond with the central atom. Chelates, according to ASTM-A380, are chemicals that form soluble complex molecules or certain metal ions, inactivating the ions so that they cannot normally react with other elements or ions to produce precipitates or skill. So it's got that shape to it. See, that's the same shape as the core of the spaceship. So andethylenediamine ligand binding to a central metal ion with two bonds. See? So it shows you how to bond the two together. Cu2 plus complexes with methylenediamine left in ethylenediamine. Chelate effect. Yeah, because the inner core has this, and then it's got a thing in the middle of it. And you'll see through the different designs, they all look the same, and this is kind of showing you what to do with, I guess these are the ligands you have to put in with the metals to get it to bend that way or something. I don't know. Ethylenediamine ligand binding to a central metal ion with two bonds. C2 complexes with methylamine and ethylenediamine. The chelate effect describes the enhanced affinity of chelating ligands for a metal ion compared to the affinity of a collection of similar non-chelating monodegenerate ligands for the same metal. Consider the two equilibria in aqueous solution between the copper 2 ion Cu2 and ethylenediamine En on the one hand and methylene can't talk today. Still morning and I'm still half asleep. In one, the bidentate ligand ethylenediamine forms a chelate complex with the copper ion. Chelation results in the formation of a 5-membered ring. An equilibrium constant K is related to the standard Gibbs free energy. So Gibbs free energy has come up in several of the videos with the ligands. I guess they're all together. R is the gas constant. T is the temperature in kelvins. H is the standard enthalpy change of the reaction. And AS is the standard entropy change. To illustrate the effect is shown in the following table. Role in polymers. Ethylenediamine, because it contains two amine groups, of course polymers come up in several videos, so you have to do a cross-reference there, is a widely used precursor to various polymers. Condensates derived from formaldehyde are plasticizers. It's widely used in production of polyurethane fibers. Pan class derivatives are derived from ethylenediamine. So these fibers, you want to use fibers with your shell, right? So I'm going to put polymer as one of the keywords there. Wolfgang Jahnke, Novartis Institutes for Biomedical Research, Switzerland, 2008. Measurements of dynamics in motion has always been one of the main assets of NMR, nuclear magnetic resonance. Now, NMR has come up several times, so there must be some sort of technology with it that's going to be used for something. But only in this and a recent suite of papers have the conformations of excited states actually been characterized. Adding weak ligands to a protein may lead to line-broadening effects without the appearance of a signal set for the complex. The structure of this invisible complex has been determined in this paper by determining chemical shifts in other NMR parameters of the complex via relaxation diversion measurements. The method makes constructive use of line-broadening effects which often occur when dynamic processes take place. Not only ligand complexes, but also excited states during enzyme catalysts may be amenable to this technique. Okay, so Google line broadening effects, f1000.com, and this physical 1977 PDF comes up. Magnetic resonance line broadening effects associated with crystalline imperfections. June 1977. It is shown that, contrary to the usual assumption, the magnetic resonance line broadening effects due to mosaic-like structures and crystalline strains from imperfections are not completely separable. We found that the angular behavior of the line broadening associated with the off-diagonal elements of the strains is the same type as the arising from the mosaic-like structure. That's prb.aps.org. There's another one, Correlated ESR and NMR line broadening effect associated with external magnetic field inhomogeneities. That's from 1979. The usual dynamic nuclear polarization DNP phenomena at the center of an inhomogeneous broadened ESR line arising from a correlated ESR and NMR line broadening have been investigated for the case of inhomogeneous external magnetic fields. It was found that DNP experimental data obtained for the central CR3 plus ESR and 27 AI NMR lines in a single crystal of ruby were consistent with the phenomenological model developed for the correlated ESR and NMR line broadenings arising from the strain and C-axis variation effects. So that's prb.aps.org. Another one is Inhomogeneous line broadening effects in 1H 2-dimensional 4-pulse ESEEM spectra of Betaine phosphite single crystals. And this one's from Germany, 1996. The effects of inhomogeneous and homogeneous line broadening on the line shape in 2 and quasi 3-dimensional 4-pulse high-score 1H electron spin echo envelope modulation spectra in single crystals of Betaine phosphate are examined. The inhomogeneous line broadening leads to a ridge-type cross-peak shape in the 2-dimensional 4-pulse spectra, whereas the homogeneous line width can be directly taken from the cross peaks. Spectral simulations are necessary for the determination of the inhomogeneous line width. The hyperfine coupling parameter distributions of protons in the hydrogen bonds of Betaine phosphite single crystals are determined. The observed inhomogeneous Broughton cross-peak line shapes indicate small local random fields in the disordered parallatic phase of Betaine phosphite. ScienceDirect.com. The next is Browse Journals and Magazines. Interdiffusion effects and line broadening of whole, intersub, and absorption in complex GaAs, AlGaAs, quantum well structures. That's from dx.doi.org. It's from Iconic Zoran. June 2010, Institute of Microwaves and Photonics, University of Leeds, United Kingdom. And there's all the people that worked on it. Abstract. Detailed modeling of absorption and in p-doped GaAs quantum wells embedded in GaAs, AIAS superlattice barriers is performed. It is shown that a careful analysis of measurements provides valuable information on the structure details, like the extent of interdiffusion and different sources of line broadening, which can be used for further design of emitters and detectors based on this and other material systems. So it's from ieexplore.iee.org. Okay? So thanks for watching, and we'll go on to the next video if we have any power left here.